Hello, this is a question related to inverse Fourier transform. We have to determine the inverse Fourier transform of a given signal by using convolution property. The given signal is capital X j omega is equal to 1 upon a plus j omega whole square. So this can be written as 1 upon a plus j omega multiplied by a plus j omega. So this can be written as first function, let 1 upon a plus j, this can be written as multiplication of two frequency domain function. Then let this is x1 j omega multiplied by x2 j omega. So we know that by using convolution property, if uh, if z omega is equal to x omega multiplied by omega, if z omega is equal to x omega multiplied by z omega, then inverse Fourier transform of zt is convolution of x and xt function xt and by t. So using convolution property, so using convolution property, I am again repeating, the given signal is xj omega is equal to 1 upon a plus j omega. I am again repeating, the given signal is xj omega is equal to 1 upon a plus j omega whole square. That is, in frequency domain signal is 1 upon a plus j omega whole square. We can write this signal as multiplication of two signals. That is x1 j multiplication of two signal. First is 1 upon a plus j omega. Let this be denoted by x1 j omega, and second signal is also a plus j omega. Let this be denoted by x2 j omega. Now using property 2, that is, if any signal frequency domain signal is multiplication of two frequency domain signal, z omega is equal to x omega multiplied by omega, then inverse Fourier transform of z is convolution of xt and by t. So using this property, now we will determine the value of zt. Now we will determine the value of xt. So xt will be, clearly xt will be, using formula 2 and 3, xt will be integration infinitive to minus infinitive, and this will be xt in convolution of by t. So we know that if the function is 1 upon a plus j omega, then its inverse Fourier transform is e ki power minus at ut. So clearly e ki power minus at ut. So first signal, so inverse Fourier transform of first signal is e to the power, now we'll write x tau, so it will be e to the power minus a tau u tau, and second signal is ht minus tau. So we will write this function as is its a inverse transform of 1 upon a plus j omega. Inverse Fourier transform will be e to the power minus at ut. We will write t minus tau function, so it will be e to the power minus a t minus tau, or u t minus tau d tau. Now clearly u tau will be 0, or tau is less than 0, and ut minus tau. Clearly ut minus tau signal u tau minus t, tau minus t signal will be like this, u tau minus t signal. will start from t. This signal is u tau minus t. So t minus tau signal will be reverse of this. So this will be like this. This will be like this. So so uh, because u tau signal is 0 for if u tau signal is 0, u tau is 0 for t when tau is less than when tau is less than 0. So and so clearly u t minus tau ut minus tau signal will be 1. Ut minus tau signal will be 1 for tau is this condition. When tau will be less than or equal to, when tau is less than, clearly when tau is less than or equal to t, when tau is less than or equal to t, then this signal will be, when tau is less than when tau is less than or equal to t, then this signal will be 1. So this integral can be written as xt is equal to infinitive to minus infinitive. Because for tau less than 0, tau less than 0, u tau will be 0. So we will consider limit from 0, because because when tau is less than 0, tau is less than 0, then this signal is 0. So we will consider only portion from 0 to t, 0 to t, because this signal will exist because this signal is 0 when tau is less than 0. So and this signal is multiplied by u tau, and this signal is 0 when tau is less than 0. So we will consider only this portion. So limit we can change from 0 to t. So it will be e to the power minus a tau. U tau will be 1, and so it can be omitted. And next e to the power minus a t minus tau, and ut minus tau will be 1 here in this limit 0 to t, and it will be d tau. So it will be integration will be e to the power 0 to t, 0 to t, e to the power minus a tau, e to the power minus at, e to the power a tau or d tau, because t is constant here. T is constant here. To e to the power minus at can be put outside, and here it will be 0 to t, e to the power minus a tau plus a tau d tau. So it will be e to the power minus at, 0 to t or d tau. So it will be e to the power minus at tau 0 to t. So it will be, so xt will be t e to the power minus at ut. So inverse Fourier transform will be t e to the power minus at ut. This can be written as Fourier transform is 1 upon a plus j omega whole square. So we have find inverse Fourier transform of signal x capital X j omega by using convolution property. Thank you.